All right, so we're going to do Chapter 5, and we're going to do Practice E, which is Conservation of Energy. So let's look at number 9 first. So we're going to always write our given and find, because our given and find help us to figure out what to do. We're also sometimes might draw a picture, because sometimes that'll help us to conceptualize a problem. So it says a 15 kilogram model plane, so that's the mass, flies horizontally at 12 meters per second. 12.5 meters per second. Calculate the kinetic energy. The plane goes into a dive and levels off 20.4 meters closer to the Earth. So I'm not really sure where it started from, but the change in the height is equal to 20.4 meters. How much potential energy did it lose? So I want to find the change in the potential energy. C, how much kinetic energy did it gain? So I want to find the change in kinetic. What is the new kinetic energy? And then neglecting friction, what's the new horizontal velocity? So there's a lot of stuff there. So first of all, maybe we might want to draw a diagram to conceptualize this. I have a plane, and it's flying along. Now, I'm not really sure what the height is of this plane, and I'm not really sure where the grounded, which I call base level. But what I know is this difference in height is what they tell me as 20.4. You see what I'm saying? So that's the difference in height. So part A says, what's the kinetic energy? So we know that kinetic energy, and that's the initial kinetic energy when it starts off, that KEI is equal to 1/2 mvi squared. So it's 1/2 of 15 kilograms times 12.5 meters per second squared. Now when I do it all on my calculator, it comes out to be 1172 joules. But let me look at my unit. I don't want to just throw that unit in at the end. So I have here a kilogram, and then when I square the 12.5, I have to square the meter and the second. So I have meter squared and second squared. But what I can do is I can pull a meter out, and I can have kilogram meter per second squared times a meter, which is a Newton times a meter, which I know is a joule. Okay. And that's just to look at my units. Part B says, find the potential energy. Well, we want to find the change in the potential energy. So the change in the potential energy is going to be mg times the change in the height. And that's what they told us was the change in the height. So that's going to be 15 kilograms times 9.8 meters per second squared times that change in height, which was 20.4 meters. Remember, I don't know the initial height and I don't know the final height. I just know the change in the height. So the change in the potential energy comes out to be 2999 joules. Now remember, on your homework sheet, everything is in correct significant figures. So this is 1170, which would be 3 significant figures. And then this one, if you had 3 significant figures, it would be 3.0 times 10 to the 2 joules. But right now, we just want to concentrate on the physics steps. Part C says, how much kinetic energy did the plane gain during the dive? So remember, this has to do with conservation of energy. Now remember, whatever I lose in potential, that's going to be equal to the gain in kinetic, just from conservation of energy. So the answer is the gain in kinetic is going to be the same thing, 2999 joules. Part D says, what is the new kinetic energy? Well, I have my initial kinetic energy. So I started off with a kinetic energy of 1172. Then I gained 299. That was the change. So my final kinetic energy is going to be the initial plus what I gained. So it's going to be the initial plus the change, which would just be adding these two together. So this comes out to be 4171 joules. The next problem we're going to do together, we're going to do more of a conservation of energy from like the top to the bottom with a little twist. And then the last part, part E, says, what's the new horizontal velocity? So if this is the final kinetic energy, I know the final kinetic energy is going to be 1/2 mvf squared. So I just need to rearrange the equation to solve for the unknown in terms of the known. So I'll multiply both sides by 2. I'll divide both sides by m. And then I'll take the square root of both sides. Do I have to do this many intermediate algebra steps? No. You do what's best for you. So radical 2kef over m is equal to vf. So now I'll go ahead and substitute in my values. So the square root of 2 times 4171 joules divided by 15 kilograms. So the answer comes out to be 23.5 meters per second. But remember, in physics, we have a foolproof way to check our work. So I don't want to just like throw in, oh, I know it's supposed to be meters per second. The great thing about physics is when you carry your units through and cancel them, you check your work. So let's do that. Over here, where if we look at my units, I have a joule divided by a kilogram. I know a joule is a newton times a meter divided by a kilogram. I know a newton is a kilogram meter per second squared times a meter over a kilogram. So now, once I stretch it out, this cancels with that, and I end up with meter squared over second squared. Well, when I take the square root of the numbers, I also take the square root of the units, so I end up with meters per second, which is the correct unit for this. So that's why, and again, you don't have to write it out like this. You just kind of look at it and you say, okay, I'm going to cancel and make sure and see if my units work out. This one had a lot of parts to it. The reason why this one was confusing was it didn't say it started off at this height and it ended up at this height. They just told you the difference in the height. So that's why this one was a little bit more confusing. But again, we're just going to look at it step by step. Remember, whatever we lose in potential, we gain in kinetic and vice versa. But the total amount of energy remains the same. Okay?